And now we're going to talk about triangle congruence by S and SAS. And we'll talk about what those mean in just a moment. Sus and SAS. Okay, so we just got done proving that triangles are congruent by showing that all the corresponding parts are congruent. But it turns out that you can also prove it using a little bit less information. You can do it using 3 pairs of corresponding sides, so we call that side, 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 or 2 pairs of corresponding sides and 1 pair of corresponding angles, which we call side, angle, side. So, postulate 4.1 is the side, side, side postulate. If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. So, like we said, postulates are accepted facts. You can try this on your own by cutting straws into pairs of congruent sides and then putting strings through them and seeing that you get the same size triangle, no matter what. Speaking of straws, let's talk about roller coasters. So let's little zoom action right here. Shows you that we use triangles to build roller coasters. So this is the drawing of that part of the roller coaster track. And using side, 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 we're going to prove that these 2 triangles are congruent. We are given that LM, segment LM, is congruent to segment NP, and that segment LP is congruent to segment NM. And we want to prove that triangle Laman is congruent to triangle Nepal. So, we're going to do a flow proof here. We're given that LM, segment LM, is congruent to segment NP. We know by the reflexive property of congruence that segment LN is congruent to itself. We also are given that segment LP is congruent to segment NM. These 3 facts combine to show that the triangles are congruent by side, side, side. That's probably the easiest proof you've ever seen. So, see if you can do it by yourself. Pause it and then push play when you're ready to see if you're a winner. Alright, are you ready to flow? Let's flow. So, segment BC is congruent to segment BF. That's given. Segment BD is congruent to segment, let's see, how are we going to name these triangles? BCD, BFD. So BD and BD, that's the order, that's the right order. So BD is congruent to BD. That is the reflexive property of congruence. And CD is congruent to FD. Segment CD is congruent to segment FD. That's given to us. These 3 facts combine to give us, let me mark my little congruent symbols up there, to give us that triangle BCD is congruent to triangle BFD by side, side, side postulate. QED. Infectious disease. You can also show relationships between a pair of corresponding sides and an included angle. So the word included refers to the angle and the sides of the triangle here. So what is an included angle? A is included between segments BA and AC. Basically, it's the angle that's made between those 2 sides. Segment BC is included between angle B and angle C. So here we're talking about side angle side being about 2 congruent sides and the angle included in between them. Okay, so it has to be 2 congruent sides and the angle that is included between those two congruent sides. So here is postulate 4.2, the side angle side postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if we have AB is congruent to DE, angle A is congruent to angle D, and AC is congruent to DF, we have two congruent sides with the congruent angle in between them, then we can say that the two triangles are congruent. So let's do a proof using side angle side. What other information would I need to be able to prove that DEF is congruent to FGD? Well, let's see. I happen to know that DF is congruent to itself. And what would I need? Here's a side and a side. Here's a side and a side. I would need these two angles to be congruent, because that would be the angle included between those two sides. So I would need to show that angle EFD is congruent to angle GDF. Then I would have side angle side. So let's see if you got it. What other information would you need besides what's given to prove that triangle LEB is congruent to triangle BNL by side angle side? Well, the reflexive property tells me that segment LB is congruent to itself. And if angle BLE is going to be my included angle, then my other side needs to be segment LE. I need this, right? Because then I would have my congruent angle included in between my congruent sides. So I need to be able to show that segment LE is congruent to BN. So that, my friends, is the information we would need. So remember back when we first started doing constructions, you learned to construct segments using a compass at a fixed angle. So now you can see why that works. You can see why these two segments are congruent and why you can use the side angle side postulate to tell you. Booyah! Because you got this side congruent to this side congruent to this side, and we use the same angle, which means that we basically made two congruent triangles. So that's why AB is congruent to CD. Bada boom, bada bing. Okay, so let's see if we can identify congruent triangles. Would you use side, 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 or side angle side to prove the triangle's congruent? If there's not enough information to prove them congruent by one of those two postulates, then write not enough information. So what do we got here? We got a side and a side with the included angle, side and a side with the included angle, so we can say those are two congruent triangles by side angle side. How about on B? We've got a side, another side, and the included angle. We've got a side, another side, and then some other angle that's not the included angle. Not this guy. This is the included angle that we really need. So we can't conclude anything there. Not enough information. How about here? We've got all three congruent sides, so that would be side, side, side. What about right here? Well, that looks like we've got, you can use either one really. Side, 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 because we've got all the sides, and we know vertical angles right here are congruent, so you could do side angle side. Boom, you can use either one. Cool, huh? You get to pick. So, what about this one? Would you use side, 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 or side angle side to prove that these are congruent? If you said side angle side, you are wrong, because the congruent angle we have on this triangle is included between the side with 2 hash marks and 3 hash marks, and the congruent angle over here is between the sides with 1 hash mark and 2 hash marks. So we don't have side angle side here, but we do have all three sides. So we would have to use side, side, side. The end. Talk to you later. Bye.